Okay, 1.2 is on combinations of functions. So, you know how with numbers we can combine them by using different operations. And what we mean by operations are addition, subtraction, multiplication, and division, right? That's the way we can combine numbers. Well, it's actually the same thing with functions. You can also combine them by addition, subtraction, multiplication, and division. And there's some handy rules here we're going to write down that show you how to do this. So, for example, if you want the sum of two different functions, what that would look like is the sum of two functions in terms of x, right? You want to take two functions, you want to add them together and see what the result is in terms of x. Well, the good news is if you want to get the sum of two functions, all you have to do is take the initial function, or one function, I shouldn't say initial, take one function and add it to the second function, and you'll have the sum of the two functions. I know this is pretty abstract. You might not be totally understanding what I'm saying here, but once you see the examples, you're going to say, oh, that makes sense. It's actually kind of almost intuitive. The difference, so we're talking about subtraction here. If you want to know the difference between two different functions in terms of x, figure out what one function is in terms of x, and then subtract the other function in terms of x. These two things, they're equal to each other. Product. If you want to know the product of two functions, f dot g or just fg in terms of x, you can probably figure out the pattern by now. You're going to figure out what f, the function, is in terms of x, and then multiply that by the other function in terms of x. And for the quotient, if you want to know what the quotient, that's division, of two functions are in terms of x, you can figure out what one function is equal to in terms of x, figure out what the other function is in terms of x, and divide them. And in this one last case here, we should actually say something about g of x. Since it's in the denominator position, what should we say? We should say that g of x cannot be equal to 0, because you can never divide by 0. Okay, so you're probably glazing over going, I have no idea what he's talking about. So here's what I'm talking about. We have two functions. Let's call one of them f of x. We can call it whatever you want. F of x, g of x, h of x, whatever. We'll call it f of x. And we have another function, g of x. So they're like two rules, right? The f of x rule says you take the input number, which is x, you multiply it by 3 and add 7. The g of x rule, or function, is you take the input number, x, multiply by 2 and subtract 4. And what I want to know is, what happens if we add these two functions together? What do we get? Well, if you look up above, it says that f plus g of x is equal to f of x plus g of x. So if we want to know what f plus g of x is, all we have to do is take f of x and add on g of x. Well, what's f of x equal to? Oh, it says right here, f of x is equal to 3x plus 7. What's g of x equal to? It's equal to 2x minus 4. And then all we have to do is combine these two binomials and we'll get our answer. Look for your like terms. You can add the 3x and the 2x, so you get 5x. You can add the plus 7 and positive 7 and the negative 4 or minus 4. So you end up with 5x plus 3. That's it. We combine those two functions. We're adding them together. All right, let's do another. Now, this is very important. The second question here, you see, is almost exactly the same except for one thing. Instead of having in terms of x, we have in terms of 5. So there's two ways you could figure this out. Basically, if it just says in terms of x, f plus g of x, you just leave it with an x in there. But if it says f plus g of 5, you need to find out what does that equal to? Like if x is equal to 5, what does that equal to? So there's two ways you could do this. One way you could do it is do exactly what we did here, all these steps here, and end up with 5x plus 3, and then substitute that 5 into x. So you'd get 5 times 5 plus 3, which equals 28. Or there's another way you could do it. Remember, if you want to figure out what f plus g of 5 is, that's the same as what's f of 5 plus what's g of 5, and add them together. So let's do it this way. F of 5, that means plug 5 into all the x's in the f function. So we're going to put 5 in right here. So we get 3 times 5 plus 7. Plus, now we're going to put g of 5. In other words, we're going to plug 5 into the g function right here. So we get 2 times 5 minus 4. Let's figure out what we get. 3 times 5 is 15, plus 7 is 22. 2 times 5 is 10, take away 4 is 6, and if we add those together, you get 28, and you will see that we have the exact same answer here as we got here. So those are two ways you can do it. You can either combine the functions first and then substitute the 5 into the x's, or you can substitute the 5 into the x's in both the two functions and then do the adding later. It's up to you. It's nice that they both work. Okay, next one, f of g of x. Okay, so in this case, there's no number here. We have to give the answer in terms of x. So f minus g, did I say f of g? No, f minus g of x is what I meant to say. So we want to know the difference of the two functions. So how do we do that? Well, if we look up above a little bit, you'll see that f minus g of x is equal to f of x minus g of x. So what we need to do is figure out what's f of x, take away g of x. What is f of x? Remember, it's written right there. It's 3x plus 7. What is g of x? It's written up there. So we're going to subtract 2x minus 4. And then we just combine. We have 3x, take away 2x. That's 1x, or just x. Be careful here. We have 7, take away negative 4. Oh, that's 7 plus 4, plus 11. Finished. Okay, next question is exactly the same, except this time we don't want to know in terms of x, we want to know in terms of negative 2. So again, there's two ways you could do this. You could either take the work we already did and plug in negative 2. That would be definitely the faster way to do it right now, since we already did the first part. Negative 2 plus 11 is 9, so there's our answer. Or the other way we could have done it is we could have figured out what's f of negative 2, take away g of negative 2. Alright, and then we plug in f of negative 2. We plug negative 2 into the x. So we get 3, negative 2 plus 7, all that. Take away, now you can put negative 2 into the g. So right here, 2 negative 2 minus 4. Let's figure out what we get. 3 times negative 2 is negative 6, plus 7 is 1. Take away. 2 times negative 2 is negative 4, take away another 4 is negative 8. So we get 1 take away negative 8, which is 9. It worked again. It will work every single time. This is what the rules up here are basically telling you, is that it will work every single time. Next question, fg of x. fg, what does that mean? That means f times g of x. So how do we figure that out? Well, if we look up the rules above, we find f of x multiply by g of x. So let's do that. What's f of x? F of x is up in green up there. It's 3x plus 7. And we're going to multiply that by g of x, which is 2x minus 4. That looks familiar. Multiplying binomials, mountains and valleys. So 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. 7 times 2x is 14x. 7 times negative 4 is negative 28. Combine the two terms in the middle, we get 6x squared plus 2x minus 28. That's pretty good. You could factor out, but it doesn't say to factor. This is good. I think you could, yeah, anyway, let's just leave it there. Okay, f of x. F of x. That doesn't mean volume for you music people. That doesn't mean do your math really loud. Haha, little music joke there for you. What that means is f of x times f of x, right? We want to know what the product is of the function f multiplied by the function f, multiplied by itself. So we take f of x, which we saw as 3x plus 7, and you could put squared there, but since we're actually going to figure out what it is, let's just write it out again. Mountains and valleys, 3x times 3x is 9x squared. 3x times 7 is 21x, and 7 times 3x is also 21x. So if you add those together, you get 42x plus 49, 7 times 7. Okay, I'm cruising now. Next, we have a quotient here, g divided by f of 0. Okay, so there's two ways you could do this. One way you could do this is that you could plug 0 in to the x's. Well, let's do it. Let's do that. You could plug 0 in for each one of these. So you could figure out what g of 0 is, and you could figure out what f of 0 is. So g of 0, that means plug 0 into the x here. So you get 2 times 0. Take away 4 is negative 4. F of 0 means plug 0 into the first function. So we get 3 times 0 plus 7. You get 7. And then what you would do is you would divide g of 0 divided by f of 0. So you get negative 4 over 7. The other way you could have done this one is you could have figured out what g divided by f of x is, and then substitute in the 0 after. So in this case, it'd be practically the same thing. Maybe I'll leave that for the example on the next page. Okay. There's just kind of more of the same here, except now we have some radical signs. You will have to do some of these with fractions, rational expressions. So I know some of you don't like that from last year. Unfortunately, they've come back again. So in this one, if we wanted to know what f plus g of x is, we'd be taking f of x and adding g of x. F of x is 2 root x minus 5. G of x, we're going to add on g of x, and g of x is root x minus 5. Combine your like terms. You can add the root x's together. 2 root x plus 1 root x, right? There's 1 root x there. That equals 3 root x. And then negative 5 plus another negative 5 is negative 10. And the domain, in this case, we need to restrict the domain because what kind of number can you not have under a radical sign if it has an even index, like a square root sign in this case? It can't be negative, so x has to be greater than 0. Can it be 0? Yep, you can take the square root of 0. So you'd need to include that in your answer. Okay, next one, we're going to do g take away 2f of x. Well, that's the same as g of x take away 2 times f of x. What's g of x? Root x minus 5. Take away 2 times f of x, which is 2 root x minus 5. So the first bracket there, no change, root x minus 5, but we have to do some mountains here. So we got negative 2 times 2 root x is negative 4 root x, and negative 2 times negative 5 is plus 10. Combine like terms again, we have 1 root x, take away 4 root x, which gives us negative 3 root x, and we have negative 5 plus 10 is plus 5. Again, we need to restrict the domain. X has to be greater than or equal to 0. Okay, fg of 4. So again, there's 2 ways you can do this. Faster way, again, I think would be to figure out what f of 4 is, and then multiply it by g of 4. So f of 4 means plug 4 into the f function. So you'd have 2 root 4 minus 5. And then we're going to multiply that by g of 4. Plug 4 into the g function. Root 4 minus 5. 2 root 4. Well, root 4 is 2 times 2 is 4. Take away 5 times root 4 is 2. Take away 5. So 4 take away 5 is negative 1. 2 take away 5 is negative 3. Negative 1 times negative 3 is 3. The other way you could do it, again, quickly, is you could figure out f of g of x first, and then plug in the 4. So if you're going to do that, and this will show you this takes a little bit more work, you'd have to find f of x, and then multiply by g of x. F of x is 2 root x minus 5. G of x is root x minus 5. If you do mountains and valleys there, 2 root x times root x. Root x and root x is x, so you have 2x. 2 root x times negative 5 is negative 10 root x. Negative 5 times root x is negative 5 root x. And negative 5 times negative 5 is plus 25. Okay, that equals, we can combine 2x, take away 15 root x, plus 25. That's what fg of x equals. If we wanted to now know what fg of 4 is, we'd plug 4 into all the x's. 2 times 4 is 8, minus square root of 4 is 2 times 15 is 30, plus 25. 8 take away 30 is negative 22, plus 25 is 3. We got the same answer. Going pretty fast here, but I'm just trying to show you that there are different ways you can do it, but oftentimes it is easier to do the plugging in of the value first and then do the multiplying or subtracting or whatever after. Okay, here's some weird questions here. We have 2 graphs. We got a black one and a blue one. I hope you can see the colors. You probably can't. This is the black one. It comes, let's put an arrow on the end here. Oh, actually, we're going to make this a pretty point. So we've got an arrow, a black line comes down. Here's another pretty point here. I know it's not perfect. It's the best I could do. Pretty point, and that ends up here, and there's a pretty point right there. We also have a blue one. You might want to take a different color or something. We've got a pretty point here, pretty point. I know it's off, but it's the best I could do. And a pretty point down there. This is going to be your g of x, and this is our f of x. So we have 2 functions. These are all the output values for all the input values, right? Like if you look at the black one here, what's f of 7. I don't know, I'm just saying anything. F of 7. Well, that means when the input 7, when x is 7, oh, I picked a good one. What's the output of the black one? The output is 0. What's G7? G of 7. Well, now we're looking at the blue function here. When the input's 7, go over to 7 for your input or your x. What's the y value? -1. So f of 7 equals 0, g of 7 equals -1. Does that make sense? We've talked about that kind of stuff before. Now what we're going to do, though, is we're going to combine functions. We're going to graph a combined function. So we're going to do, how about f of x, f plus g of x. So here's how we do this. We need to really concentrate on those pretty points, specifically their x values. So the pretty points line up. We have a set of pretty points at -9. We have a set of pretty points at -5. We have a set of pretty points at 0. We have a set of pretty points at 4. And we have a set of pretty points at 10. And what we want to do is we want to do f plus g of x. Well, that's the same as f of x plus g of x. So when x is -9, what's f of x? What's the output of that? The output at -9 is 4. So we have 4. This is our f plus g of x equals 4 for f of x plus, what's the g of x when x is -9? It is -6. So we get 4 plus -6 is -2. I'm going to write that in there, -6. I'll make it faster for me later. So one point we have is -9, -2. -9, -2. Okay, now we just do the same thing for all the pretty points. When the input's -5, when x is -5, the f of x, f of -5, is -6, and g -5 is 0. So we get -6. So another point is -5, -6. Understand how I'm getting this? So for 0, it's kind of a weird one because if we look at this point for both f of x and g of x, it's 0, so it's just 0 plus 0 equals 0, so it stays the same. Okay, let's look at this one. When the input value is 4, so when x is 4, what's the output value for f of x? The output is, the y value is -5. What's the output value for the g of x? The output is 3. And what this thing we're graphing here is we're adding the f and the g. So we add them together, we get -2. So another point is 4, -2. Sorry, -2. 4, -2. And finally for 10, we have 6 here plus -6 here. We end up with 0, so 10, 0 is a point. Okay, it's very hard for me to join these. I can't draw straight lines freehand with this, but it looks something like that. Okay, 2 graphs left. Don't worry, I'm only going to do one more. It just takes too long. So let's do f minus g of x. Okay, we're going to write down those same pretty points. So for x, y, -9, actually it shouldn't say y, it should say f minus g of x. -9, -5, 0, 4, and 10. Okay, oh, I forgot to write down all the points. So let me write down the y values, all these points. As a y value 0, -6, 0, 3, -5, 6, and -6. Okay, so what we're doing this time is f take away g of x, which is the same as f of x take away g of x. What's f of x when x is -9? When x is -9, f of x, or the output, is 4. So we have 4 take away, what's the output for g of x? -6. That equals 10. I'll go back and graph them all later. The next one, at -5, I have -6 for f of x, take away 0, so it's -6. -6, whoops. The next one at 0, it's still 0, take away 0, equals 0. That's a 6. Terrible. At 4, it would be -5, take away 3, which is -8. And for 10, what's that number up there? 6, take away -6, which is, darn it. Don't like that. 6, take away -6, which is 12. Okay, let's graph these. One's -9, 10, way up here. One is -5, -6. Sorry, I was looking at something. That's why I'm taking so long. Next one, 0, 0. Next one is 4, negative 8. And the last one is 10, 12. It's off the grid, somewhere up around here. I'll never be able to connect these ones well. Not too bad so far. Still not bad. Kind of loopy there. And that's horrible. Alright, that's the idea. Big W for Waj, and we're all done. And as for this one, I was going to graph f plus 2g of x, but you know what? I think I've had enough. If you want, I'll do 1 point. I'm not doing all of them. F plus 2g of x, that means at negative 9, you would take your f value, which is 4, and then you would add 2 times the y value, 2 times the output value for gx, which is 2 times negative 6. So you get 4 plus negative 12 is negative 8. So your first point would be negative 9, negative 8. You're welcome to finish that one off if you want. I've had enough. All right, that's it. Sorry it's so messy. Sorry it's so long. Enjoy yourselves, people.